There are matrices A and B, which are similar matrices n by n. And we know that matrix A is idempotent, which means that A squared equals A. And we need to prove that matrix B is also idempotent. Okay. So if matrix A and B are similar matrices, then there exists an invertible matrix P such that B equals P inverse times A times P. Let's square both sides of this equation. So we will get B squared equals the inverse of matrix P times A times P multiplied by the same expression, so the inverse of matrix P times A times P. That means that B squared equals the inverse of matrix P times A times P times P, the inverse of matrix P times A times P. We know that P times the inverse of matrix P equals identity matrix. So we get that B squared equals P inverse times A times identity matrix times AP. So we get that B squared equals P inverse times A squared times P. Since we know that A squared equals A, because A is an idempotent matrix, this means that B squared equals P inverse times A times P. And from the very beginning, we get that the same thing. So we know that P inverse times A times P equals B. So we get that B squared equals B. So this means that B is an idempotent matrix. Idempotent.